Hello everyone, welcome back. This is Anu here. Today we are going to discuss about another important topic in the AI world, that is called the retrieval augmented generation. Why we need the retrieval augmented generation instead of LLM? That's a very big question that we need to ask, right? Even if you have an LLM, we will get answer from the LLM, right? Suppose if there is any OpenAI model or any of the LLM model, if you have the access to them, if we ask any question, we will get the answer right. Then what is the importance of retrieval augmented generation or RAG pipeline in between when we consider about any AI system? That's what we're going to see today. Let's go ahead and see some scenario. Suppose I have an LLM. Okay, I have an LLM model. LLM model. Maybe it's from Gemini or Anthropic or OpenAI model. Okay, it is trained with very huge amount of data, isn't it? It's trained using trained. My handwriting is so bad. Okay, trained using huge data. And this is how these LLMs are getting trained from very huge amount of data. And my LLM is ready. I can ask the question to this LLM. As a user, I'll come and ask questions, come and ask the questions, and the LLM will provide appropriate answers. Suppose my LLM got trained, my large language model got trained with the data up to 2024 data. And my question was something relevant to 2026. Okay, my question is related to some news or some Olympics related data from 2026. Okay, how this LLM is going to answer this question? Do they aware about those questions, or how they're going to answer this question? Most probably, the LLM will say they don't have relevant information, and sometimes they will hallucinate or recreate some question in a creative way, or some assumptions it will be. We are not looking for assumptions. We are not looking for assumptions, isn't it? Especially if you are thinking about some medical journal, okay, medical or legal. We don't want any assumptions, right? We need factualities, okay. We need factualities. It will be factual, and we need citation from where this information has came, right? Citations. We need factuality check. We need the citation. We need the source. Okay, we need the source information about the data. Info about the data. Are these details are going to provide by the LLM? Are they able to provide this kind of information? I don't think so. There comes the importance of RAG system. Okay, importance of RAG system. RAG means retrieval augmented generation. Retrieval augmented generation. Let's see how this is going to happen. Okay, in any RAG pipeline, the initial phase will be we need to train some LLM model on the specific data that we have. Suppose I have a huge amount of internal data. Okay, huge amount of internal data, around 200 GB of internal data. Okay, I am going to build an AI system. AI system. And my AI system should answer, okay, based on this data. Based on this data, the AI system should give a response depend upon the data which I have fed it, and based on that, it should generate new response. This is what my architecture I am going to build using that. Okay, suppose the first step in any rack pipeline is data ingestion. Okay, data ingestion. Data ingestion means I'm going to ingest this data, or I am going to feed this data to the LLM. Okay, first thing is data ingestion. Okay, data. If I'm going to give 200 GB of data, it is not going to consume all the data together, right? It has to convert into small chunk of data. The smallest chunk of data that an LLM can process, these are called tokens. Okay, these are called tokens. And let's talk a little bit about tokens. Okay, token means smallest unit of data an LLM can read or write. One LLM, whether it may be ChatGPT LLM or OpenAI LLM or Sonnet model or Gemini model, whatever it may be, the smallest unit it can read or write, that is called the token. Whenever they get some data, okay, that will be converted into token. That process is called tokenization. Different models will have different tokenization mechanisms are there. Once it is tokenized, okay, that is usually um, 0.7 word is equal to one token. Okay, 0.7 word is equal to one token. This is how we are calculating in an average. Okay, data will be converted into small tokens using the process. This process is called chunking. Different chunking mechanisms are there. We are going to see what are the different chunking mechanisms. Okay, this process is called chunking. And what are the different chunking mechanisms? Based upon the requirement, we can have different kind of chunking mechanism. And we have fixed size. Fixed size means I have this much amount of tokens are required in each chunk. Okay, that is around 1024 character. It will be one chunk. Like that, we have fixed chunk size is there. Second thing is recursive character traceability. Let's go ahead and see what are the chunking mechanism available. Okay, this is the data ingestion stage. Data ingestion we can do in any format. Again, either it can be file upload or from Amazon S3 or Azure Blob Storage or cloud storage or URL or database or HTTP. We can have any kind of data source. Okay, and that also we can include any kind of data. It can be CSV, JSON, HTML, .tsg, Markdown file or PDF. We can have any kind of data. And again, if it is an HTML data, we can do HTML tag stripping. We can do. We don't need those tags. Then normally it's the white space. It will remove the unwanted white space because whatever we are going to give to the LLM, these are all going to consume the token. So before giving to the LLM, we need to remove all the unwanted data. Only the wanted data, only the information which is relevant for our processing need to be fed to the LLM for doing the processing. Okay. Then he includes source path. If we want to give the path of the source data, that also we can include the page number. These are relevant in case of any medical system or in case of any law, that is if any lawyers applications are creating those kind of systems. These kind of chunking methods are very important. Once these are selected, Okay, then we can go for this chunking strategy. Okay, what are the different kind of chunking methods are available? Already I have discussed fixed size. Earlier I thought to go to the writing method. I will go to the writing part again. First thing is fixed size. Okay, that is what is meant by fixed size. There's a uniform text documents and plain text file and structured data. Okay, these are the best suited way to take this kind of chunking methods. And when consistency matter more than the semantic coherence, in that case we can go for the fixed size. There we can decide one more thing: how much is the chunking size of, okay, token size, whether it is a 512, or we can increase this token size to higher values like 2048 and all. Then we need to think about the overlap in the sense, whenever we do chunking, we need to, the last 50 characters of the first chunk will be the initial characters of the second chunk. This is how this overlapping is happening. And then we need to consider, this is what is chunking. What are the methods chunking available? Fixed size or recursive character test splitting. That is recursive character chunking. That is the most common one. Then semantic chunking. Suppose if you want to consider the semantic meaning of that particular context, then we need to consider semantic chunking. Then the fourth one is markdown header. Okay, if you have any markdown file, depend upon the markdown header, we can do this markdown chunking. And sentence based, that depend upon new line characters and all. It will be used based on the sentence. When each sentence is finished, then it will go to the next chunk. Then paragraph based. Suppose if I want to consider one paragraph as one chunk, that complete paragraph will be saved into one chunk, and the next paragraph will be considered as the next chunk. Here the problem is, if sometimes the paragraph will be very large, sometimes the paragraph will be very small. There is no strict size for this chunk. That is a drawback for this one. Next, come to code aware. Suppose if you're going to build any coding system like Cursor or anti-gravity or VS Code kind of thing, in that case, we cannot do the chunking at the middle. Suppose if I have one lengthy function, I cannot stop the chunking process at the middle of the function. It has to have the complete context of that particular coding system, coding pattern or coding function, right? In that case, we need to consider about this code aware chunking. The final one is token aware. Okay, that is models with a strict context window. Suppose if I am using some proprietary models from Opus or from Anthropic Opus or Sonnet kind of model, which is having very high throughput and very high cost for 1 million token. In that case, I need to be very cautious about the number of token I am consuming in and out. In such kind of system, we need to think about the context or token aware chunking. These are the common chunking methods available in rack pipeline. We can configure. Okay, let's go back to this drawing board. Okay, once it is done, once chunking is, this is how this chunking is happening because of the input data. Um, Input data will be divided into small chunks. Okay, then once the chunking process is done, the next stage is once the chunking is done, that means the input data is divided into small size of data, then we are going to do this embedding. Okay, then we are going to do this embedding. What is happening in the embedding? Okay, next stage is, from the chunking we are going to embedding. Embeddings. Okay, initially I said concept about the token, right? Suppose I have chunk of data. Okay, chunk of data means there will be data is here. This data will be divided into tokens. Okay, that is 0.7 word is one token. 0.7 word is one token. Okay, the Text will be converted into chunk. Chunk is a piece of text that will be divided into equal size tokens. Equal size token. While converting token, it will be assigned with a token ID. Token ID. What is meant by this token ID? Suppose I'm going to take one sentence. Okay. The car is blue in color. This is the sentence. Okay. It is going to convert it into the below format. The car is blue in color. Okay. Each one will be divided into separate tokens. These are all the tokens. Okay. Suppose I am using for a mini model. Okay. For a mini model, for the first one. Okay. First one is the. It is having a token ID. Token ID. Token ID means, suppose if it is token ID, we can say 270 is a token ID. Whenever we are going to tokenize any sentence, wherever the word comes, it will be having token ID will be same as 270. But there is a twist. Okay, suppose if there is the same word which is coming in the middle. Okay, the cat sat on the mat. Here there is one dice there at the beginning. Okay, then one the came at the middle. Do they have the same token ID? Of course not. They are having different token ID. How it is being identified? Here the is coming at the beginning of the sentence. Okay, the at the beginning of the sentence, that means there is no trailing spaces here. At the beginning there is no spaces there, so it is giving 270 as the token ID. Whereas this one, if you see this one, there is a trailing space. There is a small space at the beginning. This will be given token ID around 745. This is totally altogether a different token ID, even though the word is same, whether it is coming at the beginning or the mid, depend upon that the token ID is going to change. This is how this tokenization is happening. Each word will be assigned with separate token. Now, in the next stage, we are going to convert this token ID into vectors using embedding technique. Embedding technique. How it is happening? It is going through different mechanisms internally. And suppose if my model, embedding model, have the dimension of 2048, suppose it's coming. It is, we have given the token ID as, what is the token ID we have given? 270, right? 270 will be converted into ones and zeros of what is the size? 2048 size. It is converted into very dense vector. This is what the output of embeddings. Now we got the input text that is given to the chunking mechanism. It went through different kind of chunking mechanism. Once its chunk is ready, then those chunk will be converted into equal size tokens. The token will be assigned with the token ID. That token ID will be converted into embeddings. Embeddings means we are converting that token into the token ID into um, the numeric format in the this binary numeric format of size that which support that dimension. Dimension in the sense dimension of that particular embedding. That each vendor have their own embedding mechanisms. Depend upon that, it will be converted into that particular format. It's a very dense vector of zeros and ones. Why we are converting this into embeddings? This is why, because in the next stage we are going to save this data in vector database. Vector database. We are going to we have this embedded data. This embedded data will be saved in this vector db. Why vector db? Okay, why vector database? We have already seen the retrieval augmented generation or any LLM model. What they are good at? They are good at generating the keyword, next word, or generating the next word. Suppose if I am asking some question, it is having a lot of semantic meaning. I don't want my system to generate any random word after that, right? I need some meaningful information out of that. That meaningful information, from where this meaningful information is coming. Suppose if I'm asking some questions, these questions should be answered in a meaningful way. How this is generating that meaningful information? That's why, because we are saying this data in the vector databases. Vector database, there is a functionality we are going to do that is called this similarity search. Similarity search using cosine similarity. Cosine similarity. Using this cosine similarity, we are going to search inside the vector db. Okay, inside the vector db, I am asking cat and animal. Cat and animal, if you see the cosine similarity, their values are near. If it is this is cat and somewhere near here will be animal. So that the distance between them is minimal. Whereas I am asking cat and aeroplane, it is somewhere not related to some other place, so it is somewhere related to some other place. When we are comparing this similarity search, even though if both the words are coming in the same sentence, it is more adhered to these two words. These are two similar words. This is how it is taking the semantic meaning of or semantic context of that particular sentence. Once we have this vector databases, our first stage is over. Let's go ahead and draw this diagram first. That is the stage phase one. Phase one of RAG. Okay. Data ingestion. Once data is ingested, it will convert into chunks. Then we are going through embedding mechanism. Once it is embedded, we are going to save this data in vector db. In the vector db. This is the first phase. In the second phase, as of now, my data is saved in the vector database. In the second phase, okay, phase two. Now a new user is coming. We have everything ready. System is ready to answer the question. Okay, new user is coming, and he's asking a question. Okay, he's asking a question. Okay, what is happening now? Once the user asks a question to this chatbot or any chat system, okay, Okay, user came to the chatbot and entering this question. What is happening? This question again, it will be converted into embeddings. Converted into embeddings. Why it is converted into embeddings? Because we need to find out the relevant information from the vector database. In the vector database, we can go and ask only as a vectors. Okay. Now we got the vector. Using this vector, we will go to this vector DB, vector database, and do a similarity search. Do a similarity search. Either do a similarity search or suppose some keyword. In that case, we'll do a keyword search. Keyword search. Either we will do a keyword search or similarity search using question similarity. And once we have this information available, it will be it will retrieve the relevant information from the vector DB. Retrieve info from vector DB. Now we have the required information from the vector DB. Along with this vector DB, I need some authenticity for this data. In that case, what are the information I'm going to add here? I'll be having some metadata. Metadata about what? Metadata about the retrieved content. Retrieved content. What are the data we retrieve from the vector DB? There will be some metadata associated with the metadata. Can be creation date, and citation information, then author, okay, book details, okay. It can be any kind of information that all constitute this metadata information. These also will be added to this retrieved information. This information also added to the retrieved information. This stage we call it as augmentation. This stage we call it as augmentation. Augmentation in the sense we have retrieved the data from the vector database. Along with that vector database, we are giving more information. We are giving more authenticity to that particular data, from where this data has came, who written this data, and when it has created this data, from which book, which page, from which PDF this data is coming, and all those information will be added. Along with that, some system prompt plus prompt will be added. Okay, suppose the user is asking a very silly question or very simple question which is max 10 words or something. In that case, what this system will do, there is a functionality called question rewriting. The LLM will do rewriting of the question. Okay, rewritten question. All this information will now we are going to pass to this generation phase. Okay, okay, we'll be to the generation phase. We are feeding this data to large language model for generating the output. Now this LLM will have access to all this information. It will start generating the output. Okay, now it has generated the output in a token format. Okay, token format. This will be detokenized. Okay, detokenized and converted into text format. convert into text format, and feed to this, feed to chat box, and we can see this output. This is how this retrieval augmented generation is happening. Very simple thing, but a lot of things happening inside. If you see this process in the input data ingestion, then convert into chunking, small chunk. E- In that chunk itself will be converted into small tokens. That token will go to the embedding mechanism. Once it is embedded, then we are going to save this embedded vectors into vector databases. Okay, send those information into the vector databases. In the phase two, that is called the retrieval phase, the user will come and chat with the chatbot, and it is they're asking some questions. That questions again will be converted into, it will go to the embedding phases and it will convert into vector, and then it will go for the similarity search. From the similarity search or keyword search from the vector DB, it will retrieve the information or what is relevant. And then again, this relevant information will be added with some of the metadata information, that is called the augmentation phase. What's it? Okay, then based on that, all the information or augmented information during the generation phase, this LLM will generate the outputs and emit as tokens. Then we will go ahead with the detokenization process, and then the text format, convert into text format, and that text will be feed to this LLM chat box. This is how this retrieval augmented generation is happening. And let's go ahead and see what are the components involved. Even though I have given these steps, there are a lot of other things which is involved in this vector database or vector processing or this RAG pipeline. Let's go ahead and see this RAG pipeline in detail. Here itself, okay, this is the RAG pipeline. Let's go ahead and see what are the components involved in each and every stages. Okay. We've already seen this chunking process. Then come to this embedding. Embedding, there are different models available that depend upon the usage or use case. We can decide which embedding model we need. Either we can go for the text embedding 3 small, or let's go ahead with the prior provider. Suppose if you want to go ahead with OpenAI model, we have from OpenAI we have text embedding 3 small or text embedding 3 large. Okay, we can choose depend upon the usage. Suppose if you're looking for general purpose or cost sensitive or high throughput, then we can go for vector embedding 3 small. Or if you're looking for high accuracy legal document or medical research kind of thing, then we can go for the text embedding 3 large. Okay, here it is giving this MBET score and cost per 1 million token and maximum input tokens, how it is, how much, so how maximum input token it can process and all. Okay, suppose if it is let's go ahead with the Cohere ranking. We have in Cohere we have text embedding 3 large, embedded version 3 English for the English language. Okay, then sorry, Cohere we have embedded version 3 and embedded multilingual version. If you're looking for a multi-language support, then we can go ahead with this multilingual version 3. Okay, it is supporting around more than 100 plus language it is supporting. Then if you are looking for some models from Google, we have test embedding 04 from Google, it is available. Or if you are looking for something from Hugging Face, okay, from we have BGE large English for Hugging Face from the Hugging Face. It is open source, self-hosted, and privacy sensitive, and air gap. And the BT score is 64, and cost per 1 million token is 0 because it's a self-host. We can self-host this model. Maximum input token is $5. That is one drawback. It's very small input tokens. And we have EFA large version 2, open source, multilingual support, and general purpose. And all mini LM. This is about prototyping, edge deployment, or resource constraint, or high throughput. Then we can go for this one. These are the different embedding models available across different vendors. From Nomic, we have Nomic Embed Test, which is good for long document, open source, and large context, because the maximum input token it can handle at a time is 8,000 192, that is 8 MB at a time. Um, Depend upon the tire. This we can use this filter for doing the trade-off. Suppose if you user is having different budget allocations and all, then depend upon that we need to decide which model we had to go. That's why I have decided this application to go in this one based on different filters. Okay, a provider filter, which tire, whether it is a fast model or balanced or advanced model we need. Then quality, whether it is excellent quality, need good or fair. And speed, very fast or fast, medium, slow. If you see the very fast model from all provider, let's see which one is very fast. All tire, quality on. I'm only looking for very fast model. Or let's go ahead and see the rest of the phases. Once it is embedded, then we need to save this data into vector databases. Let's see in vector database, what are the different vector databases available. Okay, we can go for managed one. Managed one means this will be managed by those particular companies. It's a Qdrant managed one. Pinecone, there is a Pinecone managed one. Then Vertex A, that is from the Google, and Azure ASS, that is from the Azure. Or if it is a self-hosted one, we have different self-hosted ones are available. From Qdrant, we have self-hosted Weaviate, OpenSearch, or PG Vector, we have the self-hosted vector stores are available. And then come to embedded one. Embedded one, we have Chroma and FAISS. We can use embedded one. We don't need any vector databases to save this kind of DB. It will be within our system itself. Or suppose if you need something related to hybrid search means keyword plus semantic search, then for embedded FAISS is giving that is Facebook AI similarity search FAISS, that is giving both embedding and both keyword and a similarity search. Suppose if it is a managed one from Pinecone, it is giving this hybrid search, and Azure AI search is also giving hybrid search. And self-hosted one, in the self-hosted one, we have Quadrant, Weaviate, and OpenSearch is providing this hybrid search. Depending upon the use case, we need to select which vector DB we need. And then we are going to, once up to this phase, that means our input data has been processed and embedded and put it into vector databases. Then come to the query processing. Query processing onwards, the user comes in and asks the question. Okay, suppose if we need to enable query processing, the user may ask a very silly question, simple question. But we need to give some elaborate answer or some trustworthy answer. In that case, what we need to do in query processing stage, we can give that particular query into a small model which is self-hosted or which is very less costly. Then we can either do query rewriting or a hide technique or multi-query expansion or query decomposition or step back prompting or intent classification, keyword augmentation, entity assertion. We can do any kind of this permutations and combination depend upon our use case. Okay, then we can go to the retrieval stage. Okay, in the retrieval stage, how we are going to retrieve this data. Okay, what are the kind of mechanism available in retrieval stage? In the retrieval stage, either we can go for the similarity search. It will do the keyword similarity search and it will identify the top care documents, or MMR technique we can use, or a hybrid. It will do the keyword search and semantic search, or parent child retrieval, or multi-query retrieval, or ensemble RRF technique we can use for retrieval. That depend upon which use case we are going to work on. Then comes to re-ranking, we will discuss later. Okay, then come to context compression, enable context compression. That means depend upon whether it is depend upon relevance or near duplicate summaries. Depend upon that we can do the compression of the context, because always the context matter. All this context will be converted into vector. tokens, and those tokens are going to cost us too much. So in that case, how we are going to handle this cost? Here comes this context compression comes into picture. We need to compress the context based on any of this a parameter, either it is a relevance filter or near duplicate removal or summarize that is sub trim to the first chunks. Okay, based on that, this context will be compressed and given to this system for retrieval. Next, we are going to do this re-ranking. Re-ranking in the sense, suppose if I am asking some question in the vector database, there will be 50 chunks will be having the information, relevant information. Okay, I don't need all the 50 chunks to pass to the LLM, because if you see one chunk, that will be around 1500 characters or 1500 tokens. Suppose 1500 tokens are there for one chunk. If I'm going to pass around 50 such kind of chunk, it is going to cost us too much in the generation phase. I don't want to do that. Before going to that stage, I'm going to pass this 50 chunks into a lower model, and where we are going to do a cross encoding with this input query, so that what are the relevant information it was retrieved from this previous stage, that is from this vector DB, we have retrieved few chunks, around 50 chunk of data we have retrieved. On that data, we'll be doing cross encoding. This is going to reduce the chunk from 50 to 5, top 5 or top 3. Okay, it is going to reduce to top 5 or top 3. Only those top 3 are the most relevant information we need to pass to the LLM. Okay, let's see what are the models available for re-ranking. From Cohere, we have Cohere re-ranking model is available. That is, it's not the relevant information. Let's see. BG is not from Cohere. Okay. From that is from the Hugging Face. Cohere re-rank, we have re-rank version 3. That is Cohere re-rank version 3 is available. Suppose if you want to go for Hugging Face, from Hugging Face we have BGE re-ranker or cross encoder. MS Marco is available for re-ranking. And how many records we need, either top 5 or top 10, how many records we need, that also we can configure. Then next phase is called the generation phase. We have given all the information. Next phase is called the generation. This is where this RAG pipeline is costing us very too much. Okay, suppose that depend upon the which model we are going to select. Suppose if you're selecting the latest Anthropic model, it is going to cost each 1 million token is going to cost around $15 to $25. So this is where the trade-off has to come into picture, and we need to analyze each and every model and cloud provider and the model output and all. Based on that, we need to select that particular model for generation, and that has to come in within the limit of the monthly budget. Okay, I don't know whether it is going to show you the cost cutting. Yeah, now I have selected which model. Now I have selected GPT-4o or 4o mini. Okay, if you are selecting GPT-4o mini, the cost will be around $88.9 per month. Suppose if you're going to select GPT-4o and then see how much it will be the cost. Now GPT-4o monthly cost is skyrocketed from $86 to $1090 per month, around $1,000 per month. Whereas if you are selecting this model to Opus 4.7 or Sonnet 4.6, let's go ahead and see if it is Opus 4.7, how much it will cost. We are going to see. And $6,865, that is $6.8K per month it is going to cost us for this particular rack pipeline. Whereas the second model from Anthropic, that is Claude Sonnet 4.6, how much it is going to cost? It is going to cost around 1,393. It is similar to what you have seen in GPT-4o. Okay, like that, depend upon the use case, we need to select which model we need to select. Whereas if you select Gemini for 1.5 Pro, Gemini Flash, first select the Gemini Flash, and the cost will be $56.95 per month. Whereas GPT 1.5 Pro, it will be around 557, 10 times the Flash model. And there are different other model like Mistral Large. How much it will be for Mistral Large? It will be 817, bit higher than the GPT 1.5 Pro. Llama 370 billion parameter. This one costs on 229 in between. It's a moderate amount. And Commander, this is advanced one. That's from Cohere. It is going to cost around 1090. It's similar to a GPT-4 model. This is where this cost cutting is happening, or cost trade-off has to happen. Depend upon the use case and depend upon the complexity of the output we need. We need to consider which model we need. Once it is done, then we have to go for the routing, LLM routing. Okay, conditional routing, what has to be done, and we have to which model this has to go. Okay, conditional routing for different LLM from based on the rules and fallback mechanisms and all, it will be routed to different LLM models. Suppose I am having different LLMs are available. Suppose if the first model is not available, if that were deprecated, how this has to be deprecated? It has to be routed to the second model. This is all the routing and fallback mechanism comes into picture. Okay, fallback model, we can select any of this fallback model. Sorry, we can select any of this fallback model. If the primary model is not working, then it has to fall back to the secondary model. If that secondary model is also not working, then it has to fall back to the tertiary model. This is what this conditional routing is. Based on the rule, we can add keyword match or query length or semantic complexity or semantic routing or cost aware, latency aware, confidence routing, tool routing. And based on the rules also, we can set this kind of LLM routing. Once the routing is configured, then we can go for memory. In rack pipeline, suppose if you're going to chat with that system, it is going to remember your conversation for a while. And how it has memorized this conversation, how much amount of chat history it has to keep, what kind of memory it has to keep, that we can configure here in this memory stage. Memory stage, we can have conversation buffer or summary buffer or vector memory or entity memory or episodic memory, depend upon which memory state we need to keep, that we can configure. And how many conversation, how many messages it need to keep, that's we can configure. That is window size. That is called the window size. Either it can go up to 100 messages you can remember in the, or you can keep it in the memory, that we can save. If you want, you can persist this across the server register. Even that means it is going back to the databases and it will be saved there. And when if there is a restart happening, we can resume from that stage. Then go to the important stage. The next few phases are very important. One is called the evaluation. Once we create the RAG pipeline, it has to go through the evaluation phases. That is called the RAG evaluation or RAGAS. Okay. Once we enable this evaluation, okay, different stages are there. It is going to evaluate the faithfulness, okay, answer relevance, content precision, contents recall, latency, groundness, safety, human evaluation, and retrieval in the CG. These are the things it is going to be evaluated. These are very important because when we create a track pipeline, we need to analyze, continuously monitor, and see whether these answers which is getting generated using the rack pipeline are up to the mark or not. Continuously, we have to get the feedback from the user. There will be some grounded truth answers will be there. We need to compare with that grounded truth data using these evaluation pipelines. Okay, we can do this evaluation on demand or on a continuous or periodic, if it is in a production, on a periodic state, we have to do this continuous evaluation. Once the evaluation is done, then the complete ecosystem has to be fed to this observability tool, monitoring and observability. Okay, what are the things we can do? Token usage tracking, latency monitoring, retrieval tracking, prompt tracking, tracing, and all this kind of things we can do in the observability and monitoring stage. Okay, then we need to consider about if there is more tool involved, we need to consider including those tools also into this monitoring stage. These are all going to help us in security related aspects or audit related aspects. Okay, suppose if you want to add any adaptive policies, we can give the rules, okay, which predicate or which action has to be taken on such kind of predicate. Then comes to the another important topics in the RAG pipeline, that is called the guardrails. Guardrails that is being implemented in three stages. One is input stage, then retrieval and output stage. These are the three stages this guardrails can be implemented. Input, that is PII reduction. If there is any personal information available in the retrieved content, that has to be removed, that has to be cross-checked. That is meant by PII reduction. Then prompt injection block. If there is any prompt injection is happening, that has to be blocked. Toxicity filter, any toxicity information is there in the input text, that has to be filtered, removed, and then fed to the system. During the retrieval, that is checking phases. This is the user query. This is during retrieval from the vector DB. We need to filter out the content and source validation. Source validation we can do from citation and other, we can say, source validation and the path where this data is residing and from which document it is happening and all. Just retrieved and all. Those information we can do using the source validation, and basic heuristics analysis also we can do during this retrieval. Next, come to the output phase. Output phase means once the data is done, retrieved from the LLM, then it has to feed to the user using the user interface. Before leaving our AI gateway, we need to do this output guardrails. Output guardrails means hallucination check we need to do, a faculty check we need to do, and citation verification we need to do, so that we can make sure that this information are up to the mark. Then come to the important part is human in the loop. Even though everything can be automated using AI, then we need to implement the human analysis or human intervention at some point of time. This can be done in different ways on different stages. I have segregated into simple, medium, and advanced layer of human in the loop. Okay, if it is a simple, then which level human has to involve, either as a reviewer or approver or corrector or escalation handler or trainer or data curator. These are the human roles we can assign, and which phase we have to assign, whether it is a pre-ingestion or that is during the data ingestion phase, the phase one, pre-ingestion stage, or retrieval time. We need to include the human in the loop, or the generation time, or post-response time, when we need to include this placement of human in the loop in pipeline. Then if it is medium, then we have few more functionalities, that is confidence and escalation. Suppose it will suppose if the system is generating a confidence value for this particular generated output, if the retrieval score is below this value, then we need to consider about the re-ranker value, and based on that we can include this LLM uncertainty or self-check signal escalation. Okay, either we can do soft, or we can warn the user, or hard, that is require approval, silent, route internally, or deferred, that async review queue, or human will take over the discussion, like that. That also reviewer workflow, we can include any of them, either reviewer, approver, coordinator, escalation handler, trainer, or data curator. That depend upon which one we are going to set. Then when it come to advanced level, a few more things we can add, like advanced orchestration governance. Okay, which governance mechanism we are going to do for this orchestration, whether it is a land graph or temporal or AWS step function we need to do, or perfecto, Komodo, or Airflow. Which kind of orchestration we need to take care when we consider about this rack pipeline. That is what this advanced human in the loop. Okay. Suppose land graph I'm selecting, then I need to select between agentic tool, or API call approval, or multi-reviewer consciousness, or human guided retrieval, or right, or that depend upon which one we are selecting. Then these are the major steps involved in retrieval augmented generation or RAG pipeline. Okay. This is all about. Let's see whether it can be popped out. Okay, this is the sample architecture of a retrieval-augmented generation or RAG pipeline. So we have this input data source. It can be from any of this location file upload, or S3, or GCS, or Azure Blob, URL database, or API. Then that will be ingested and pre-processed. Once it is pre-processed, it will go to the chunking process and chunking. Then it will be embedded using nomic embedded text, or what are the model we are selecting. Then it will be saved in this vector databases. That process all there. That is the first stage. In phase two, user comes and asks the query. Then if required, that question will be done. Question transformation will be done like hiding technique or multi-query or split or question rewriting and all. Then it will go to the episodic memory, then go to the guardrails. It will check all this guardrails, input guardrails and all. Then it will give to this retrieval phase. Retrieval phase, then it will go ahead and this question will be converted into chunk and vector, and those vector will be taken to the vector database and do the keyword and similarity search. Then in the next phase, it will go to the content compression, then re-ranking method, and finally it will be going to the router and fallback mechanism, to which model it has to be routed. If there is any fallback mechanism is there, then it has to go to the fallback mechanism. Then it is going to the generate phase, or it is going to the LLM and it will generate the output. Okay, once output is generated, it will review we can give a feedback loop to review the answer whether it is met the goal or not. If it met the goal, it will given to the end user. If it doesn't met the goal, then it has to go reiterate through the loop and finalize the output. This is the general architecture of a RAG pipeline. Was not that much good. So let's go ahead and see this architecture. This is RAG pipeline architecture will be almost same everywhere. So let's go ahead and see. So this is the ingestion phase. That is PDF from these three, or Notion API or Google Drive. GitHub, from wherever we need, we can have this data ingestion. It will be given to this ingestion phase. Either it can be through webhook or pool or a dedupe or something, and it will be given to this partition mechanism. It can go to OCR or partition mechanism, text extraction, unstructured data layout, and converting unstructured data to structured data format and all. Then it will go to the chunking phase. Okay, it can do recursive character or ATS aware. That depend upon the chunking strategy. We have already discussed a lot of chunking methods. Then it will go to the embedding phase. Once it is embedded, then those vector will be saved in this vector databases. In the vector database, we are going to save this DB metadata and ACL triggers, and all this information will be saved in this vector databases. Now, in the phase two, this user query is come into picture. User will come and ask the question. It will go to this AI gateway and API gateway. Regarding the AI and API gateway, I already created one video. You can go ahead and watch that video. Then it will go to query embedding state. That question will be embedded into vector. Then it will go for this retrieval. That question will be converted into vector, and vector will go to the vector DB and do the similarity search. Then once we have the details, then it will go for this re-ranking method, prompt builder, and LLM. It will be fed to the LLM. After re-ranking and prompt building, it will go into the LLM. Either it is a Claude or Gemini or OpenAI models, and it will do the final result and feed it, giving it back to the user. This is how this RAG pipeline is working. That's all about this retrieval augmented generation. Thanks for watching this video. Have a good day. Bye.